Okay, this is topic 9-7. Now we're going to be dividing radicals. We've added, subtracted, and multiplied. That was our last lesson. Today we're dividing. So let's see what we get. Now, some of this I reviewed at the end of the last lesson, but we're going to go and hit it again. The square root of 3 over 16 is the square root of 3 over the square root of 16. Well, the square root of 16 happens to be 4. So our answer is just the square root of 3 over 4. This was really nice because the 16 was a perfect square. It saved us some hassle, which you will see in problem number 2. Now there are a couple of ways to work this. I want to go ahead and split this in half so I can show you both ways. The first way is the way I generally go to first. I will look at this and go, well, I need to multiply by the square root of 3 over the square root of 3 in order to get rid of this radical on the bottom. Because I know that the square root of 3 times the square root of 3 is just 3. And on top, this will give me 21 times 3 is 63, square root of 63. And so I take 63, I know that that is 3 and 21, which is 3 and 7. I get a pair of 3's with a 7 left behind. And so I have 3 on the square root of 7 over 3. Those 3's will cancel, leaving me with the square root of 7. Now this is a longer route. It happens to be the route that I usually choose though, because you don't always get to divide these numbers. However, you can also solve it this way. This is the square root of 21 over 3, which 21 divided by 3 is 7, so it equals the square root of 7. This method happened to be a little bit faster for this, and the reason was because 21 does in fact divide by 3. So I'm going to be going over and using the method that I feel is better for each individual problem. Let's go and talk about number 3. Well, when you're dividing radicals, much like when you're multiplying, you can take the outsides and divide, and you can take the insides and divide. Well, 8 divided by 4 is 2, and 48 divided by 2 is 24. And so we have 2 on the square root. Well, 24 can be simplified. So we take that 24. I know that it will divide by 2 and give me 12, which I know is 4 and 3, which is 2 and 2. I have a pair of 2's. That 2 and 3 are independent. So 2 times 2 makes 4. And 2 times 3 make 6. And so this is my answer. Alright? And that was easy because 8 divides by 4 evenly. And 48 divides by 2 evenly, making this rather nice. Again, multiple ways to work out this problem. Let's go and talk about number 4. Well, I can't take a regular number and divide by a square root. So instead, I have to multiply by a fancy version of 1. Because this is 1, I'm not changing anything. Square root of 2 over the square root of 2 times the square root of 2 is 2. And up here I get 12 on the square root of 2. Well, 12 over 2 makes 6 on the square root of 2. We only have 2 more problems. So let's go ahead and go over number 5. Here we have 3 over 7. This is the square root of 3 over the square root of 7. Well, they won't simplify at all. And I can't have a radical in the denominator, so multiply by a fancy version of 1, which gives me the square root of 21 over 7. And 21 won't simplify because it's 7 and 3 and there are no pairs. So that's the answer. And we'll do the exact same thing for number 6. 5 and 11 won't simplify, so the square root of 5 over the square root of 11 times square root of 11 over square root of 11, fancy version of 1. We get the square root of 55 over 11. And that's as much as we can solve our answer. So, dividing radicals, not difficult. Hopefully you'll be able to choose the best method that works for you. On this worksheet, this method will probably be your best bet because this method simply takes longer. If you simplify first, and then you solve your radicals. And then multiply by, well, simplify first, multiply by the bottoms, and simplify again. So, this was the assignment. This is a very short video. Hopefully you enjoy the break. Have a good afternoon, and I will see you in class.